Practice paper year 1 maths exam, learning outcome 2, question number 4. This is an integration question. Velocity is given by this function here, 2t squared plus 3t minus 5, and it's shown below. Also have a look at questions within the section 48.2 to 4, page 435 in the old textbook, 457 in the new. There are some other questions on integration, indefinite and definite integrals, and you'll see solutions to the questions in the exercises available as video clips. So let's have a look at this particular one. So part A says, explain why finding the total value of the area under the curve between limits 0 and 2, ignoring the sign, would involve 2 integrations. Well, if you look at it, you can see that if we just did the straight integral between 0 and 2, we would have the positive side of this integral, which would be the top bit of the curve, minus the bottom bit. If we want the actual area, ignoring the sign, then I'd have to do 2 integrals. One integral between 1 and 2, and the other integral between 0 and 1 to get this area, and then add the areas together, ignoring the signs. So evaluate between 0 and 2 this integral. So let's, what we'll do, we'll just do the limits directly and see that we'll end up with a fairly small positive number doing it that way. So what do we do? Following the conventions for integration. So they're all going to involve the first standard integral, which tells us to add 1 to the power and divide by the new power. So this is going to equal, for the first one, 2t cubed over 3, adding 1 to the power and dividing by the new power, plus 3. T to the power 1 becomes t squared divided by the new power, minus 5, and that particular one, if there's no variable, the variable just reappears between 0 and 2. So what I'm going to do now is just try and tidy up if possible, which, looking at it, I can't, and then I'll put in the limits. So this equals, so using curly brackets, I'll put the top limit in first, so that will be 2 times 2 cubed over 3 plus 3 times 2 squared over 2 minus 5 times 2. So that's the first limit put in, and then we subtract the next limit, which is going to be 2 times 0 cubed over 3 plus 3 times 0 squared over 2 minus 5 times 0. So that's all going to come out to be 0, and we'll end up with 2 2s 4, 2 4s are 8, 8 2s are 16 over 3, plus 2 2s are 4, 4 2s are 12 over 2, which is 6, minus 10, which equals 6, 12, 18, so 16 over 3 plus 18 over 3 minus 10. So what does that turn out to be? 18, 28, 34 over 3 minus 10. 34 over 3 is 11 1/3, so that minus 10 becomes 1 1/3, or 1.3 recurring. Quite a small positive answer, as we anticipated. You might want to now carry on, although not asked, and work out what each area is between 0 and 1 and 1 and 2 as an extension question, and see what you get the total area to be underneath the curve. So in this case, I would have to do 2 integrals. The integral between 1 and 0 of the function, which is 2t squared plus 3t minus 5. With respect to t, And then the integral between 1 and 2 of 2t squared plus 3t minus 5 with respect to t. And then add those two areas together to get the total area underneath the curve. Have a go at it, and you'll see the answer, the total area calculated for you below to check with. And leaving the answer in fractions, you get exactly 7 billion.